From my, yes, this is from 2 notes. What? No. That's my name, evidently. I almost thought about getting a picture of me with a rope around my neck, 2 ropes. I was thinking about it. I was in my barn thinking about it this weekend, thought, right, while I was working on my tractor. Okay. No, I do not ride my tractor to school. Okay. Sorry. Okay. I need to refresh your memory about some things. This won't take a long time, but I do need to refresh your memory. Okay. We're dealing with right triangles first. Of course, I'll also remind you of Frito.
That just remind me of turkey. That's crazy.
For right triangles only. For right triangles only. Frito, don't try to use SOHCAHTOA on a non-right triangle. You'll hurt yourself. We don't want to do that. Okay, so.
My brother said to say hi.
Oh, tell your brother I said hi. All right, now back to the real math. So the sine of an angle measurement, right, we'll call it the sine of theta, according to what we remember from SOHCAHTOA, is what? What do the O and the H stand for? Opposite over hypotenuse. And the cosine of an angle measurement, theta, is, what's the A stand for? Adjacent. Stay with me, children. Adjacent over hypotenuse, and then obviously opposite over adjacent for tangent. Suppose we had a really nice 3, 4, 5 right triangle. And I ask you for these 3 values. What's the cosine of theta? You could even leave it as a fraction.
Cosine of theta is going to be maybe
what? 4 over 5. Is there anybody in the room that thought they were supposed to find an angle measurement? I hope not. You are only asked to find the cosine of the angle measurement, which is a simple fraction, 4 over 5. Yet year after year after year, I ask the same question on a quiz or test, and guess what I get? I get an angle measurement. Now, I'm not sure why, because all I asked for was the cosine of the angle. If I ask you for the angle, that'll be a different question. But this is just the cosine of the angle. Well, what about the sine of the angle? Opposite over hypotenuse is 3/5. And what about the tangent?
3/4.
3/4, right? Opposite over adjacent. Very simple, easy fractions for your answers. If I did ask you for the angle theta, what would you do? Take a guess. Grab your machine.
Oh yeah, you gotta add that.
Let's make sure the mode on our calculator is in degree mode. Switch it over to degree. Yes, even you, sir. Okay. How can we use Miss Braithwaite? Pick one of these. Pick one of them. Which should I use? Which of the 3? Doesn't matter what. Sine. She'd like to use sine.
She saw a sign.
She opened up her eyes, I know. Okay. So how do I use this to get rid of sine and just leave theta on the left side? Take the inverse sine, right? The inverse sine of 3/5. So sine inverse 3 divided by 5, and what approximate angle measurement do we come up with?
Oh wait, no, this was
36.9 degrees? Lots of times I ask for cosine theta, and what I get is 36.9. And I'm thinking, okay, I just wanted 4/5 for that question. I'll ask you later about an angle measurement. So if you need an angle measurement, angle measurements are found by using things like inverse cosine, inverse sine, inverse tangent. But because you had all three of these, you could pick. That's why I asked her which one she wanted, and she picked sine, and that's fine with me. You could use cosine or tangent just as easily on this particular question. In a story problem, when you're talking about angle of elevation, angle of elevation is measured from the horizontal up. You know, usually like when you're standing on the ground and you're looking at the top of a building or a mountain or something like that. That's angle of elevation. We have those situations in story problems when we talk about the angle of elevation, and I get people who start measuring this part of the triangle as if this is the angle of elevation. Would that be a good angle to use? No. It can give you a bad value. So they also use a phrase like angle of depression. It makes you sad? I'm so sorry. Angle of depression. An angle of depression is measured from the horizontal which way? Down. So you're measuring this angle right here for the angle of depression. Sometimes I get kids that start drawing a triangle like this one right here, and they measure this as the angle of depression.
Don't do that.
Nope, don't do that.
Wouldn't that be the angle of elevation?
Is it measured from the horizontal up? No. This would be the angle of elevation. Oh, geometry people who have studied parallelograms. Angle of elevation, angle of depression. Oh, aren't they the same? How do we know that?
They're parallel.
All the lines are parallel. Therefore, this line, that's true, because the line is called a transversal, and it splits the parallel lines, creating, what are these called? Not a parallel universe, no.
What are they? They're called
Alternate interior angles. Yes, thank you. Geometry was a success. So this particular example, which you see in the book, example 1, is just a story problem situation where they mention angle of depression, and they say that it's 26 degrees. So when you're thinking about drawing your triangle, keep in mind where the measurement is. Or if they were talking about a helicopter or an airplane and it's moving in for a landing, try to draw a triangle as if you were in the airplane, you know? And it goes out straight like this, right? Like if here was sorry. And there's the guy on the wing, you know, the discount double check guy. You know, it's about yeah. So anyway,
I'm surprised you made that joke in French, Sam.
Why? It's a hilarious commercial. Okay, just because it pays him lots of money. He's a nice guy, even though he's on the wrong team. Anyway, so
Tom Brady did work last night.
what?
Tom Brady did work last night.
I
think he
don't
did.
even want to talk about that.
Yeah,
I think he did
That's
he outplayed
disgusting.
He did a very good
Well, he
job.
did a good job.
You know,
He did a good job. They were a little bit lucky there at the end, but you know, They made it. All right, so the angle of depression. So when you have these airplane situations and you got this airport down here, please make sure that you realize we're measuring from the horizontal down to the line of sight with the airport. Okay? And what would you call this distance in terms of airplanes?
The height, the altitude.
Altitude. So sometimes we'll use the word altitude. Yes, that's the distance. If it were to fall straight down. Not that we would want that, but Okay.
Did somebody just say that we're planning the plane to drop straight down? There are people on that plane.
You did.
I did not say that.
There's only one guy. This is the drone with a discount double check guy on it.
Yeah, in the commercial, there's Aaron Rodgers on that plane.
No, he's not there. They're not there. They're not there. He was just, somehow he got on the drone.
It would parachute down before it crashed.
Whoa.
Okay, next. 1 degree is equal to how many minutes? Oh, I know you've never seen that symbol before, but that stands for minutes. Okay. And a minute, we have 60 of those in a degree, just like time. Like 1 hour equals 60 minutes? Yeah.
Or 1 day equals 60 seconds.
Now we can call that TV show 1 Degree. Wasn't my best work, but it was off the cuff. 1 degree is equal to how many seconds?
1 degree.
62.
60 seconds. 1 minute is equal to 60 seconds. Hey, this sounds a lot like time.
What about...
So how many, 1 degree is equal to how many seconds?
3,600.
Yes, 60 times 60 would be 3,600. So 5 degrees, 22 minutes, and 37 seconds is equal to what decimal number of degrees? Okay, so we're going to convert this from degrees, minutes, and seconds into a decimal.
Is this what our next chapter is over?
Well, chapter 5, yes, section 1. So, how would we convert this part? What would we divide it by to change it to degrees? 60. This is already in degrees. This is now in degrees. What would we divide that by to change it into degrees? 3,600. Now, each part is in degrees, and we can add them together using the handy-dandy machine. 5 plus 22 over 60 plus 37 over 3,600. Okay? So this is the number of degrees. 5.37694. Repeating. Sorry. Not terribly difficult. If you had to go back the other way, suppose we started with 14.729 degrees, and we wanted to change that back to degrees, minutes, and seconds.
Oh, well, first.
Well, the first one should be easy, right? 14. It's the .729 that we got to deal with. So first, take the .729 and change it to degrees. How do we change it to, or minutes? What are we going to multiply by? 60, right? Now that gives me 43.74. So I know this is 43. But I've got to deal with the .74. So what am I going to do? What am I going to multiply that by? Now keep in mind, it's been changed into minutes. So now you're taking .74 minutes and changing it to seconds. So now you want to multiply by 60, right? And your math teacher didn't pick one out that was nice. It was random. Sorry. Usually we like to pick nice ones. Now, you're going to find some of these situations like in example 2. This isn't a difficult question. A surveying instrument is 4.5 feet above the ground. You do have to take that into consideration. A surveyor marks a point 50 feet from the base of a cliff and measures the angle of elevation to its top to be about 61 degrees 39 minutes. Okay, there's where the fractional part's coming in. Find the height of the cliff. So you'll be drawing a picture, and on that picture, you'll be finding, are you using SOHCAHTOA, yes or no? It's a right triangle, correct? You'll be finding this side of the triangle, and then after you, listen to me, after you find this side of the triangle, what do you have to add to it? 4.5. You do have to take that into consideration in these questions. Not a lot of difficulty here, even example 3, which is a ramp. When they say it has a slope of 1/12, listen to me. Hey, slope, which one of those 3 trig functions are we talking about? Sine, cosine, or tangent? Tangent, right, because opposite over adjacent. It's not difficult because we know that we would be inverting to find an angle measurement. So these aren't difficult questions. We will be doing more of these tomorrow. And you need to watch the 5-4 notes, and everybody else will be watching you since you just got recorded to YouTube.